I'm a big fan of effect, and today I will show you how you can integrate Drizzle with an effect service to expose an effectful API to your database. I will show you how you can derive effect schemas from your Drizzle tables and use a TypeScript helper to make sure they are always in sync. Then we'll build the core service and expose two important functions, runQuery and transaction. runQuery executes a single statement on your database as an effect. Transaction wraps the transaction function from Drizzle, and instead of running the transaction as a promise, it will run the transaction as an effect. So you get all the benefits of effects, while keeping the fact that if an error occurs within your effect, the transaction will be a rollback. Also, we'll see a few bonus, like how you can run a few initializing statements when you create the service on your database, and also how you can control whether you should migrate or not and migrate automatically. Let's go. We're going to implement all the features one by one from scratch, and all the code will be available on GitHub for future reference. So the first step is to take a look at the package.json so you can see what you need to install. In the dependencies of the project, you have libSQL client. We'll use SQLite, and I like this client, but everything we do in this video is also applicable to any database supported by Drizzle, so MySQL, Postgre, and so on. You have to install the Drizzle kit for migrations and pushing the database in development, the Drizzle ORM, so we can integrate with the database, and finally, effect. I will use buns throughout this video, so here is how to install everything. You just run bun install, and you are good to go. So the first step is to create our schemas for the database. So here in the database service folder under src, we create a new file called schema.ts. So we start with a bunch of imports to define our tables in Drizzle. And I like to create a default timestamp column. So it takes a name and returns a specific way to create a timestamp in SQLite because you have multiple ways to do it. So usually I do an integer with a mode that is timestamp millisecond. So everywhere in the tables when I need a timestamp column, I will use this shorthand. Then I create a bunch of common columns that I will use in any table. So first the ID, which is an integer as primary key, and a createdAt and updatedAt column, which have default, so the new date, so the time of now, when you create a new record or when you update a new record. Finally, in this example, I will just have a single table, the to-dos table. So we create a table here, we spread all the common columns, and we have then the title, which is the text of the to-do, and the completed column, which is only a boolean stated whether the to-do is completed or not. Now it's time for our first integration. We want to derive an effect schema from our table so that it's easier to parse input and output for our APIs. To do so, here we create a new file called dtos.ts. DTO stands for Data Transfer Objects. So here the first step is to import our schema and the infer select model from Drizzle. It will help us derive the type of the select model for a database table. Then we create a helper function. It takes a schema as input and returns the schema. But the magic is here in the types. So it takes as a generic the type of the schema, and then we say that the schema should extend the schema from effect with the corresponding type. So it means that if the schema you define is different from the type here, you will get an error in TypeScript. Let's see how it works. So here I create the common types for the schema. So if you remember, we have the ID, a number, the createdAt and updatedAt as date. Then I create the type to do that I infer from our table, so the schema.todos, and I create the corresponding schema in effect using the struct. Finally, I just export the to-do schema, but first I pass it through my function ensure schema with the type here of the infer select model. So the magic here is the following. If I made an error here in the to-do schema, I would get a TypeScript error. So here, let's say I forget to declare the title. I did it. here I get an error, and this error tells me that I forgot to add the title, so this type here is not the same as this type here. And as you can see, as soon as you add the title, it solves the error. So it's a bit of manual work, but there is no official Drizzle effect schema implementation, and I like to do that, so at least if I make a mistake, I have some TypeScript error and my project does not build. Next, it's time to create our database service in Effect. So we go in our folder and we create a new index.ts file. We start with a bunch of imports, and then we create an helper function. It's an effect that will just create the database or load it from the disk. So here we need to first read from the configuration, so the .env file that will be loaded by Ben, the place on the disk where the database is. Then we initialize a client by using the create client from libsql. So it's the client for SQLite. And then we create the DB instance from Drizzle by providing the client and the schema. Finally, we return the DB. The final step before defining our service is to define an error. I like to do that for all my services. So I create a database error that extends a tagged error. And it has an optional message and a cause, which is the error that occurred. So it's useful because then every error that occurs in my service will be wrapped into this class. And so then it's easy using Effect excellent error handling to match specific errors in your program, whether it's a database error or something else. Then we can create our service. So here I use the class definition by using the effect service helper. So it creates a tag and the implementation directly. We have here an effect where we define the content of our service. So we start by just a simple log stating that we initialize the database service. And for now, we return nothing. The first step is to check the DB. So we get the database here. And I like when I use SQLite to execute a bunch of pragma statements. So here I use the effect try promise to run all those pragma. So foreign keys on, journal mode, wall, and so on. So it's same defaults that I like to use, but it's not mandatory. Then the next step is to migrate the database if we need to. So I like to have in the environment variables a config called should migrate. And if it's true, then we use the migrator from Drizzle to run the migration. So again, here we use the try promise, we migrate, and as you can see, we catch any error and we wrap it into our database error. It's the same here for the pragma statements. The next step is to define the runQuery. So runQuery is a function that will help us run a statement on the database in a safe way as an effect. So here we basically say that runQuery takes as parameter a function that takes as parameter a client, which has the type of our DB, and return a promise of type T. So here the T is a generic. Then it will wrap this promise into an effect using effect try promise and catch any error and wrap it into a database error. So super simple here. We just say that we take any promise that you gave me here that use the database and I will wrap it into an effect. Finally, we expose a few things from our service. So we expose the DB if we want direct access to the database. I expose the schema so that it's easier to make queries from any service, because sometimes you need to read the content of the table when you make select statement or insert statement or update statements. And finally, the runQuery. So you can access this function that return an effect anywhere where the service is loaded. Before we move to implementing the transaction, I want to show you how we can interact with our service already and show you in some context why the transaction is important and what kind of problem it will solve for us. So we import a bunch of things here, and we have to create a few test cases. So the first one is get all to-dos, not transaction. So it will just try to get all the to-dos in the database but without running any transaction because it's not implemented yet. So we create an effect using the effect generator function. And here we just yield our database service and extract the runQuery and schema. So as you can see, it's a neat API. Then we can just take as a result the outcome of this effect. So runQuery, as you remember, it takes a function that has as input the database and run a statement. So it's a promise wrapped into an effect. So here we run select from schema.todos and we display the output. I will show you in a bit what we get. Then I create an helper called simulate failure effect. So it's an effect that fails with a random error. To be useful later, you will see. Then we create the second example that will illustrate why we need the transactions. So here, let's say we create the insert to-dos with error and no transaction. So as before, we have our database service with the runQuery and schema, and we run a bunch of inserts. So this effect will first insert a first to-do here, second to-do, then it will fail. So we simulate a sleep just to have time to analyze. And then we run a third one. So what do we expect here? We expect that at the end of this effect, the state of the database will be only 2 statements inserted. And in some cases, we have a problem because we would like to have the whole work in the effect to be atomic. Either we do all the statements against the database, we manage to run all of them, or we run none of them. So we roll back the transaction. And you will see there that we get into this issue. Now, I will create here a with logging function that wraps an effect and add a few logging so we can analyze what happens. So first of all, we will use the supervisor. It will be more useful when we will use the transaction, but we create it already. So the supervisor is a way to monitor an effect and see how many fibers it uses as children. So as you might know, effect uses fibers to execute programs. So an effect is just a lazy computation. So it just represents what you want to do. And the fiber, which is a virtual thread, similar to a thread, but it's not really a thread, executes the code described by the effect. So here I create a supervisor and a policy. So we run it every 500 milliseconds. And we have a monitor fiber. So this effect will print the number of fibers. So just the length of the active fibers. So all the children will be of the effect we monitor will be counted here, the children fibers. Then we have monitor fiber, so it's just a schedule. So we repeat the effect using the policy and we fork. So it will run in the background and start monitoring how many fibers we are creating. Then I create a log state function. This one will just run the select to do and print it. So we can see the state of the database. And finally, we use effect.supervise with our effect and the supervisor. So it says run this effect and supervise it using the supervisor we just created. And we pipe with a log state. So if it's successful, we'll just log the state. So we see the state of the database. Otherwise, we print the error. We log the state again. So if there is an error, we also want to see the state of the database. And finally, we catch all so we don't pollute the terminal with the stack trace. Then I create an helper called cleanup. So this helper will just delete all to do. So every time we run the program, we first run the cleanup. So we start with a fresh database. And as an helper, I create a layer that provides the database and a logger, the logger pretty. So it's better to visualize the logs in the terminal. And I create a managed runtime that has all those layers. So now we can run any program that needs the database service and that we want to run with the logger pretty using this runtime. it avoids having to always provide the service when we run. So as you can see here, you can just use runtime.runPromise cleanup, so it will clean up, and then we run either of our example. So let's start with the first example. So run promise, and we run get all to dos, no transaction with logging. So let's go to our terminal and run src test. So as you can see, the database is empty, so it's normal, we get nothing. But as you can see here, we see a bunch of things. So our database service is initialized, we set the pragmas, we start executing the test. We have 0 fibers because we do not spawn any new fibers there. We don't have the transaction yet. We'll see why in the transaction. So it's just the main fiber, but my main fiber has no children. It's itself executing the effect. Then you see the state, so no effect, it's an empty list. And that's it for this example. So now if I go back and I comment out and enable the run with error, and as you can see, we get an error. So simulated failure, it was the error we simulated. And the state of the database after the error is we have 2 to-dos inserted, but we wanted 3 or nothing. So this is the problem when you don't choose a transaction. If an error occurs, you will end up in a state that is undefined, so you won't have what you expected to have in your database in the end. So let's take a quick look at the Drizzle documentation for transactions. Transactions works as a promise. So you have here a transaction function on the DB, and it takes as parameter an asynchronous function, so that returns a promise. And whatever happens here, if the promise fails, you get a rollback. So basically, the transaction starts, you have a save point into the database, you run the statement, and if you have an error in the promise, it will roll back to the save point. So nullifying all the changes you made to the database, which is really convenient because in many cases using SQL database, you want to use this feature of atomic transactions. So going back to our example, we need to work a bit to add these transaction capabilities. Because here, what we want to do instead of having a promise here, we would like a function called transaction, which takes an effect as input, and if the effect fails, we roll back the transaction. So we have a bit of work to make that work in our program. First step is to create a transaction context for the effect. So the transaction context has this type. It has a generic here, which symbolizes the success value, and it takes a function. The function here, I just use effect helper to extract the type of getDB. So it takes a client, it's like execute. So you have the client, and you return a promise that results with you, and you wrap it into an effect. So then you get a database error or a success of type U. So it's similar to execute. Basically, the transaction context says, I need an execute, but that works with the transaction instead. Here we'll create a transaction context using the context generic tag. So it means that we can access this value using dependency injection. Now, the next step is to rename our runQuery into execute, because runQuery will be a bit smarter than simply executing statement on the DB. So the execute is like before, we take the DB as input, and we return a promise, and we wrap that into an effect. So execute a statement on the database as a promise and return the success value or the database error in the effect. Now we can implement query and be a bit smarter. So the query now takes, as before, the database and returns a promise, but we don't want to always use the database. We want to first check whether we have a transaction context. Because if we have a transaction context, it means that we should use the transaction context to execute the statement on the database. Otherwise, we just use the DB. So here we get the transaction context using service option. So it's an optional context, meaning if it's not there, we won't have an error, but null option. We extract it as get or null. And if it's not null, we use the takes wrapper. Otherwise, we use execute. Run the query will either use the DB or the transaction context, depending on the scenario. Now we can work on the transaction, which is the most complex part of this program, but it will show you a bit of the cool features of effect. So our transaction here is a function that takes as input an effect. This effect represents the transaction. So we want that whenever this effect fails, we roll back to the save point. Okay, it's similar to Drizzle, but instead of a promise, we have an effect. Okay, how do we wrap that? If you remember, here our problem is that the transaction works that way. It's a promise. So somehow we want to start this transaction, await an effect, and then if the effect fails, we want to roll back. Otherwise, we want to continue with the succeeded value. It's not that straightforward to do, but if you approach it with the good tools, it's relatively easy in effect. So first, we use the effect runtime, so we can capture the runtime and all the services. What does it do is we kind of checkpoint the actual state of our effect runtime. The runtime has all the services that are set up. So if you create some tags and provide implementation and so on, at this point we capture all the context. Now, from the runtime, we return a function using runtime.runPromiseExit on the runtime, and this will return here the runPromiseExit function. The runPromiseEffect function that we get from this step is a useful function that allows us to run an effect as a promise. So if you pass an effect to this runPromiseExit function, it will run the effect, provide all the services. So here, all the services we captured. And it will return us an exit output. So the exit is useful because it doesn't fail the promise. It just gives you whether it worked or not. And if it failed, it just gives you some detail about the error and the problems it occurred. Now, we use useful ways to create an effect here. It's effect.async. Effect.async gives you takes a callback here that provides you a resume function. So it says basically you can integrate effect with code that works with promise, and to say that the effect is done, you just call the resume function. So this effect will wait until you call resume. And depending on the content of resume, if it's an error, if it's a failure or a success, it will either fail or succeed. So now that we are within this async context, we can use db.transaction. So we start here. We create the transaction promise. We have here the TX. So TX is the transaction client. And now, if you remember, we want our effect to have access to the transaction. So first, we create a takes wrapper. The takes wrapper has the shape of the transaction context tag that we created before. So instead, it's similar to execute, but instead of providing to the function here the DB, we provide the transaction client. Here we do a trick, so we just type it as DB, because it's not exactly the same type, but the DB type is enough and will give us all the function that you can run on the database, like insert and so on. Okay, so now we have our effect. If you remember, the effect that represents the transaction, and we will provide it the service of the transaction context tag. To do so, we use provide service. We say For this effect, provide the transaction context, and as value, provide TX wrapper. So now our effect will have the transaction context set with the TX wrapper. So if you use runQuery within the transaction, it will access this instead of the DB. Because if you remember, we made runQuery be smart. So it checks before in the transaction context if there is something. If there is something, it uses this value. Otherwise, it uses the DB. Now, we use run promise exit on our effect TX. And it's the key part. Because now, if you remember, we are still in the transaction of Drizzle. So we are in the database. But we want to run our effect. Remember, so we use run promise exit. And what happens is you have the main thread that is currently executing your code. And this main thread is the main fiber, let's say. And when you do await here run promise exit, it will create another fiber, execute it, wrap it into a promise so that when it's finished, you get back the result. So here we await using run promise exit. So temporarily we'll have a second fiber, and when it's done, we wrap it just with a succeed here. We just write succeed on the terminal, or we write failure, and we get the exit. So whether it worked or not. If it worked, we call resume with effect succeed. So we say, okay, async, now you can resume. Or we roll back and fail. So effect fail or effect die here. So at this point here, we call resume anyway. And whenever we call resume, this effect is done. And that's how we wrap our transaction. So now we can just provide transaction here. And we can dive into the example so you can see how it works. So let's go back to our test file. And now we'll add another example that will show you how to use transaction and that they work as expected. So we create the test case insert to do with error and transaction. So it's the same as before, but instead of running the statement here, the run query within just a simple effect, we run it within the transaction. So here now we have run query, schema, and transaction, and we start our transaction. So that's how you use it. You have yield transaction. So it's because remember it's an effect. It's a function that takes an effect as parameter and returns an effect. And the effect here is first you yield the query insert one time, two time. Then we enable here the simulation, the effect failure simulation, and we run the third one. Okay. And finally, here we have another slip just so we can analyze. I will show you real quick how it works. So here we can use our insert with error and transaction. We can go back to the terminal and run the example. And as you can see, now we have nothing here. Even though we got an error in the middle of our statement, runQuery was smart enough to use the transaction wrapper. And since the transaction failed, we rolled back, so we got no error. We got no to-dos here at the end of the database. Now, just for the sake of the example, I will show you what happens if we disable the error. So here, let's say I remove the problem, and then we run it. And as you can see here, we get our final output, which is the 3 to-dos. Now, I want to show you why here you see different numbers of fibers. And in transaction, it's important because, as you remember, we use the run promise exit function that spawned another fiber, wrap it into a promise, so we can await an effect as if it was a simple promise. So here, if I run the same, if I run the other example, you see that the number of fiber is always 0. It means that we have only one fiber, the main fiber that runs, but this fiber has no children fiber. Okay. Now, if I rerun the one with the transaction, you will see that when we enter the transaction here in the first sleep, we have one fiber, so it means there is a children that is running. It's the transaction. And then we have 0 when we go out of the scope. So you see here, if I spend a bit more time, you'll see the number multiple times. It means that we have only the main fiber first. When we run the transactions, there is a second fiber. It's the fiber that executes the transactions, that capture all the services, runs the transaction. And when we finish, so this fiber is done, it goes back to the main thread and keeps going, and then we go back to 0 children fibers. I thought it was cool to show you this concept so you understand maybe better how effect works and how we implement and how concretely work the transaction wrapped into an effect. So that's it for today. It's a bit of a longer, deeper dive, but I thought it was important so you know how you can build a product-ready effect service to interact with Drizzle. So you can run query, you can run transaction, you can migrate the database, you can run pragmas, and you can also derive schemas from your tables and make sure they are always in sync. I hope it was helpful to you, and don't forget to like it if you enjoyed the video, and see you in the next one.